Okay, in this lesson we're going to talk about factoring complex trinomials. Recall that previously we had factored simple trinomials, and that was a situation where a, in the standard form of a trinomial, a was equal to 1. In a complex trinomial, a does not equal 1, and a cannot be factored out. So common factoring is out of the question, and a is not equal to 1. In order to factor, we need to look for two numbers that add to b in the middle, which is just like we're usually doing, and that multiply to a times c. A times c. If you think about it, this is exactly what we were doing when we were doing simple trinomials, except that a was equal to 1, and therefore a times c was just c. This time around, a is going to have a number, and so we need to include it when we are figuring out what our two numbers are going to be. Let's do our first example here. 3x squared plus 13x minus 10. You can immediately tell there's no opportunity for common factoring. There is no numerical coefficient there's no factor that all of the numerical coefficients have in common, and there is no variable that you can remove from the terms. So I'm stuck with doing a complex trinomial factor. I'm going to write out my big X over here, multiply, and add. I need two numbers. We're going to do add to 13 and multiply to 3 times negative 10. 3 times negative 10, and in that case it's negative 30. Two numbers that multiply to negative 30 and add to 13 are 15 and negative 2. And this is where the process of decomposition comes in handy. I'm going to split this up. 3x squared plus 15x minus 2x minus 10. Okay, I'm going to common factor my first two terms. I can pull out a 3 and an x, leaving me with x plus 5. And out of the second two terms, I can common factor out a negative 2, leaving me with x plus 5. Okay, that's pretty easy. Once again, I'm going to factor. I'm going to pull out my x plus 5, and I'm left with 3x minus 2. Okay, we can see here how the group factoring, the decomposition method, was very useful. Okay, I'm just going to write a little note. Once again, decomposition. Let's look at our next example. 6x squared minus 17x plus 12. Okay, we are looking for two numbers that add to negative 17. And we are looking for two numbers that multiply to 72. Those two numbers are going to be negative 8 and negative 9. Okay, let's go ahead. Let's decompose here. 6x squared minus 8x minus 9x plus 12. If I had put the 9x in front and the 8x behind, it would have been pretty easy to see what we could factor out, but that's okay. You're going to end up with the right answer. From my first two terms, I can factor out a 2x, leaving me with 3x minus 4. Once again, I'm going to decompose. I'm going to factor out here. I'm going to factor out a negative 3, leaving me with 3x minus 4. Okay, I'm going to common factor out. So I common factor out my 3x minus 4, and I'm left with 2x minus 3. Let's do another example. 2x squared plus 9x plus 10. Draw my x off to the side here. My two numbers need to add to 9 and multiply to 20. In this case, my numbers are 4 and 5. Let's decompose. 2x squared plus 4x plus 5x plus 10. I common factor my first two terms. I can pull it a 2x, leaving me with x plus 2. For my second set, I can pull it a 5, once again leaving me with x plus 2. When I factor out the x plus 2, I'm left with 2x plus 5 as the final solution. Okay, let's flip it over, do a few more examples. 3x squared minus 8x plus 4. Okay, we need to add to negative 8 and multiply to 3 times 4, which is 12. Two numbers that add to negative 8 and multiply to 12 are negative 2 and negative 6. I'm going to break this down. 3x squared minus 6x minus 2x plus 4. I common factor my first two terms. I can pull out a 3x, leaving me with x minus 2. And from the second one here, I'm going to pull it a negative 2, leaving me with x minus 2. I factor out my x minus 2's, and I'm left with 3x minus 2. Notice how when I first decomposed, 3x squared minus 6x minus 2x plus 4. The negative 6 and the negative 2, that's different than the order that I had written them in my x. It's not a problem, I was still able to factor. But I was looking ahead and I said to myself, well, if I write the negative 2 first, if I write 3x squared minus 2x, I can only factor out an x. Whereas if I put the negative 6 first, well, 3 and negative 6 have something in common beyond just the x. And so it was easy for me immediately to identify that there was going to be a 3 and an x coming out. It doesn't matter the order that you write them in, but this is an example of making a thoughtful decision to help yourself out and lessen the cognitive load as you're doing these types of problems. Okay, let's do two more examples. 2a squared plus 5a minus 12. Set up our x over here. We need two numbers that add to 5 and multiply to negative 24. In this case, we're looking at 8 and negative 3. Let's go ahead and decompose here. 2a squared plus 8a minus 3a minus 12. We're going to common factor my first two terms. I can pull it a 2a. I have an a plus 4 left over. And in my second pair, I'm going to pull it a negative 3, once again leaving me with a plus 4. Okay, I common factor out the a plus 4, left with 2a minus 3. And in our final problem here, 6m squared plus 11mn plus 4n squared. So I've thrown two variables at you. Once again, we're going to ignore the n's just for now. Ignore the n's just for now. I need two numbers that add to 11 and multiply to 24. That's easy. That's 8 and 3. So let's add them up. Let's decompose here. 6m squared plus 3mn plus 8mn plus 4n squared. Common factor my first two terms. 3m is what I can pull out, and I'm left with a 2 plus n, because 3mn divided by 3m just leaves me with a 2. In my second pair here, I can pull out a 4, and I can pull out an n. I'm left with 2m plus n. Oh, my first bracket here should also have an m. Okay, I could tell there was something a problem because these two brackets didn't match up, and then I realized I made a little mistake. M squared divided by m, I should have written an m here. So 3m times 2m plus n plus 4n times 2m plus n. Let's common factor out my 2m plus n. I'm left with 3m plus 4n. Let's just check our solution here, just for the sake of it. We're going to check by expanding. Two m plus n times 3m plus 4n. 2m times 3m is 6m squared. 2m times 4n is 8mn. 2n times 3m is 3mn, and n times 4n is 4n squared. Combine my middle two terms here, my like terms. I'm left with 6m squared plus 11mn plus 4n squared. You can see that's identical to the original question, and therefore we have factored correctly. Well done.